In this video, we're going to talk about what we call the complex numbers. The complex numbers. So far in our study of mathematics, we've only been dealing with real numbers, whether it be a whole number, a natural number, an integer, a rational number, or an irrational number in this chapter with the square roots of like 2 and 3. All right, but now we're going to open ourselves up to what we call complex numbers. When we first started studying radicals and we looked at square root, we looked at the example, the square root of negative 81, and we said that this was not a real number. What we're going to find out in this section is that we're now going to be able to write the solution in a succinct way using what we call the imaginary unit I. Okay, so since we are going to do this definition, the imaginary unit I, it's just I, is defined as the square root of negative 1. Okay, and so what I'm going to do right now is I'm going to start looking at some powers of I so that I can see some of the patterns that may arise. For instance, let's say I try to figure out what I squared is. Well, if I take I and I multiply it by itself, I get I squared, right? So I times I is I squared. Well, since I is given by the square root of negative 1, well, I'm doing the square root of negative 1 times the square root of negative 1. That's the same thing as the square root of negative 1 squared. And so if I squared that square root, we said before that those operations are inverses, so they cancel with each other. So we're going to be left with negative 1. So this tells me that this I squared is the same thing as negative 1. All right, now I'm going to go from I squared to I cubed. In order for me to get from I squared, right, so we're going this way, from I squared to I cubed, I just multiply I squared by I, right? That'll give me I to the third power. Well, I already know that I squared is negative 1, right? So this is going to be the same thing as negative 1 times I. And negative 1 times anything is just the negative of that thing. So I cubed is negative I. Okay? Now what I want to do is I want to go from I to the third power to I to the fourth power. Well, all I have to do is multiply I to the third power times I. All right? And so if I do that on this side, I'm going to do it on this side of this equation. So I get a negative I times I, which is negative I squared. All right? When I multiply, like x times x is x squared. And if I have a negative on the outside, it's going to stay there. And I already know what I squared is from right here, right? This told me right here what I squared was. And since I squared is negative 1, this is going to equal a negative 1, which is a positive 1. So I to the fourth power is positive 1. All right? I definitely want you all to memorize these 4 here. All right? So I is just I, so that's not hard to memorize. But I squared is negative 1. I to the third power is negative I to the fourth power is 1. Now I'm going to go to I to the fifth power. Now for me to get to I to the fifth power, let's erase this square root of negative 81. All right, all I have to do is multiply I to the fourth, take I to the fourth, and multiply it by I. Well, from before, I to the fourth is the same thing as 1. So this, I to the fifth power, is going to be 1 times I, which is I. So that's another one. All right, you don't necessarily have to memorize that one. All right, now let's go to I to the sixth power. Well, all I have to do is multiply I to the fifth times I. All right, so I'm doing it on that side of this equation here. So I'm going to do it on the right-hand side. I get I times an I, right? That's the same thing as I to the sixth. And I times I is I squared. But we already said over here that I squared is negative 1. So we get negative 1. So I to the sixth is negative 1. Let's go to I to the seventh. And some of you may notice a pattern, right? I got I. When I do I to the fifth, I get I. I squared, I got negative 1. When I did I to the sixth, I got negative 1. So I went I, negative 1. Some of you may guess that this is going to be negative I, but let's see if that is in fact going to be true. To go to I to the 7th, I multiply I to the 6th by I. If I do it on that side, I'm going to multiply negative 1 times I, because that's the same thing as I to the 6th. And negative 1 times I is a negative I. Notice it's the same thing as I to the 3rd power. All right? And again, if you notice this pattern, I'm going from I, negative 1, negative I to 1. I, negative 1, negative I to 1. And so here, this is going to be an I, negative 1, negative I, 1. All right? So if I start with I to the 1st power, like this is I to the 1st power, I get I to the 2nd power is negative 1, I to the 3rd power is negative I to the 4th power is 1. All right? This is a pattern. Now, all I do is I memorize these 4 here. All right? Either memorize them or be able to develop them. All of the other powers, because I'm going to want you to be able to do I to the 99th power or I to the 257th power. If you notice, this exponent here is a 5. This exponent here is a 9. If I divide 4 into 5, I get a remainder of 1, which is this exponent on my I here. If I divide 9 by 4, I'm going to get a remainder of 1, right? So when we divide by 4, our remainder is 1, right? That means when I simplify this, I'm going to be left with just I, as in I to the 5th and I to the 9th did. All right? When I divide, go to this 2 here. I squared is negative 1. If I divide 6 by 4, I get a remainder of 2. Okay? If I divide 10 by 4, I get a remainder of 2. So anytime I look at an exponent and it has a remainder of 2, when I divide it by 4, my solution is going to be negative 1. All right? Let's look at I to the 3rd power. When I divide 7 by 4, I get a remainder of 3. When I divide 11 by 4, I get a remainder of 3, right? That's the same as the exponent, I to the 3rd. When I divide by 4 and I get a remainder of 3, my solution is going to be negative I. All right? Here, I have I to the 4th power. It equals 1. Well, when I divide 8 by 4, I get a remainder of 0. When I divide 12 by 4, I get a remainder of 0. So when I get a remainder of 0, when I divide the exponent by 4, my solution is going to be 1. All right? So I'm going to use this knowledge to help me simplify some powers of I. Let's look at these examples. All right? First example, I to the 20th power. Well, let's say I look at this I to the 20th power, right? Let's say I divide 4 into 20. Right? You really don't have to do this, but 4 goes into 25 times, and remainder is 0. And so if I want to simplify this, then I go to my little chart here. Well, I got a remainder of 0, and when I get a remainder of 0, I'm going to be like I to the 4th power, which is 1. So I to the 20th power is the same thing as 1. Let's go I to the 34th power. Well, let's divide 34 into 4. 4 into 34. It goes 8 times. 8 times 4 is 32. I get a remainder of 2. And so I'm going to scroll up. When I get a remainder of 2, this is going to behave like I squared. And I've remembered that I squared is negative 1. And so my solution would be negative 1. Let's go I to the 51st power. Well, let's divide 51 by 4. 4 goes into 5 one time. 4 goes into 11 2 times. So I get a remainder of 3. And so when I get a remainder of 3, it behaves like I to the 3rd power. And I know that I to the 3rd power equals negative I. And so I to the 51st power is negative I. All right. So when I have these types of examples here, I'm either going to want to see as my solution an I, a negative 1, a negative I, or a positive 1. All right. I don't want to see any powers higher than 1 on that I. All right. And that's how we simplify those. All right. So that's working with powers of I. Now we want to get to the real real reason why we want to study these things. All right, because it opens us up to having expanding our number system and finding solutions to square roots where there's a negative in there. All right. For instance, I have the square root of negative 100. All right. Notice that that negative is in there. All right. We already know that the square root of 100 is 10, but since that's a negative, all right, and the square root of negative 1, as we've defined it as our imaginary unit up here, is I, then instead of having this be 10, since that negative is in there, my solution is going to be 10I. 10 times I. Okay? So anytime I have a negative under my radical, I'm going to have an I when I bring it out. All right? And this is most simplified. We want to see those I's. We don't want to see those negatives under those radicals. Let's look at number part B. The square root of 72. Okay? Well, of course, 72 isn't a perfect square, right? But if we look at our list of perfect squares, 4, 9, 16, 25, 36, 49, 81, sorry, I forgot 64, 64, 81, so on and so forth. The largest one on that list that goes evenly into 72 is 36. So I'm going to write this as negative 36 times 2, okay? Now that I have my perfect square, all right, it is a negative, so when I take the square root of negative 36, it's actually going to be a 6i, and then my square root of 2 remains there, all right? Now, when we normally write these, I normally like to write my i's out front so that I won't confuse myself to having that I out back, but when you write your answer, it's 6 square root of 2 times I, okay? Now, I just put this little dash here or whatever you want to call that so that I make sure that my I is on the outside so it won't get confusing. All right, but this will be my final answer here. Notice there's no negatives under my radical anymore. Let's look at some other examples. Actually, before we get to other examples, we're going to actually talk about complex numbers, which is the title of this section. All right, complex numbers can be defined as any number or numbers that can be written in the form A plus BI, where A and B, we were doing good with that, where A and B are real numbers, and I equals the square root of negative 1, okay? So we have A and B are real numbers, and B, sorry, I is our imaginary unit there. If I can write a number like that, then that's what I'm calling a complex number, all right? This part that doesn't have an I is called my real part, and this part that does have an I is called my imaginary part. Okay, so we have a real part and we have an imaginary part. And what we're going to do is when we see numbers like this and we want to add, subtract, multiply, and divide them, we're going to kind of treat I like we would normally treat a variable, all right? Kind of like we would treat x. So kind of think of this as like a plus bx. We're going to treat it the same way. But we're going to remember that when we want to simplify, we got to remember that I is just I squared is negative 1, I to the third power is negative I, and I to the fourth power is 1. Let's look at some examples. So in part A, we have an addition. I have 9 minus 2i plus 17 plus 6i. All right. Of course, since we're going to be treating these like variables, we are only going to be, combining our like terms. So if I look, 9 and 17, even though they're in parentheses, remember it's separated by addition symbol. We're just going to combine like terms. So 9 and 17, negative 2i and 6i are like terms. And so if we want to simplify this, 9 plus 17 is 26, and negative 2i plus 6i is 4i. So we get 26 plus 4i, and this is how we're going to leave our answer. We're always going to leave our answer in a plus bi form. A plus BI form. All right. Well, our next example is a multiplication of these two types of numbers, right? So think of this as an 8x and a 15x. But what we would normally do is we multiply the 8 and 15, and if you think about it, 8 times 15 is 120. And if that was an x times x, we'd write it as x squared. So I'm going to do the same thing, except for it's I. So I times I is I squared. Now, we're supposed to write our answer in A plus BI form, right? That's the definition of the form where we have a definition of our complex number. Notice that the only power on the I is 1, all right? And so I can't have an I squared. And so instead of writing I squared, before we said that I squared is negative 1, and so I'm going to write it as 120 times negative 1, which equals negative 120, okay? So if you notice, complex numbers with no real parts, all right, positive times a positive will give you a negative. All right, that's something different. We don't really want to memorize that, but that's what we have there. All right, part C is a little tricky, and I want us to think about it. All right, and this is where one of the definitions that we studied before kind of comes into play. All right, what we would normally do if we had, and I'll go ahead and write this like this, the nth root of A times the nth root of B, is we would normally write this as the nth root of A times B. But we can't do this in this case because we had to know for a fact that these two were real numbers. Okay? If we knew that those two things were real numbers, then we could do that. Now we can't do that. We do not know that these things are real numbers. And so what we're going to do here is we're going to kind of make them complex numbers. They are complex numbers. But when I have a negative under my radical, in order for me to get rid of that negative under my radical, I'm going to have to take the square root of negative 1, which is I. So I'm going to write this as I times the square root of 7 times I times the square root of 28. Okay? Now, both of my i's are on the outside. So remember, when we have something on the outside of a radical, we can multiply them together. I times I is I squared. And now that there are real numbers, or positive numbers under my radical, I can multiply the 7 and the 28. So I have 7 times 28. And if you put that into your calculator or think about it, I get an I squared. We get the square root. I squared times the square root of 196. All right. And if you think about it, 196 is a perfect square. All right, but we have I squared, which is negative 1. The square root of 196 is 14. And so our solution would be negative 14. Okay, negative 14. All right, so be careful. We can only use this rule if we know that these two things are real numbers. Since it wasn't, we had to make sure that they became real numbers. And after we knew that they were real numbers, we applied this rule right here. All right, let's look at one more example. And this example includes stuff that looks like binomials. All right, and remember, we're treating I kind of like we would treat a variable, but this time when we have an I squared, we're going to always remember negative 1. All right, so what we would normally do is use our FOIL method. So I'm going to FOIL. 6 times 10 is 60. 6 times 3i is 18i. Negative 5i times 10 is, it's going to be a negative 50i. And a negative 5i times a positive 3i is a negative 15i squared. Negative 15i squared. Of course, we're going to want to combine our like terms. Of course, we can see these like terms in the 18i and the negative 50i. So we'll have 60 minus 32i. Note here that this I squared, we're going to change that to a negative 1. All right. And a 15 times negative 1, if we were going to simplify this, that's going to become a positive 15. Right? If we simplify that. And so we have a 60 plus 15, which is 75 minus 32i. And again, this is how we're going to want to leave our answer, right? A plus BI form, all right? Or it can be A minus BI form if that BI is negative. All right, so that's multiplying. Now we're going to do division, all right? Now, when we have an I in our denominator, right? For instance, this example here has 8 over I. Well, remember that I is the square root of -1, all right? So we actually have a radical in our denominator, all right? And what we said before was that we don't like radicals in our denominator. We want rational numbers in our denominator. So what we're going to do here is basically the same stuff that we did before when we had division with radicals in our denominator. We rationalize the denominator. Rationalize the denominator. And so instead of changing it to a radical, I'm going to leave it as this form right here. Remember when we had one term in our denominator, in order to rationalize the denominator, we multiply by the radical on the denominator. So I'm going to multiply the top by I, and I'm going to multiply the bottom by I. Okay? When I do that and I multiply across, I get 8I over I squared. Okay? Well, we said before that I squared was -1. And if I divide something by -1, it's just the opposite sign that it has. So since that's a positive 8I on top, it's now going to be a negative 8I. So 8 over I is the exact same thing as negative 8I. Very interesting. Let's look at another example. Part B, we have 8 plus 3I all over 5I. Again, I'm going to multiply the top and the bottom by the radical that's in the bottom. The only radical that's in the bottom is I, okay? So I'm going to multiply the top by I, and I'm going to multiply the bottom by I, numerator and denominator. Now, I don't have to multiply by 5I over 5I. 5 is not a radical in my denominator. I is the only one, okay? And so with this, I set myself up for a distributive property, right? I'll get 8I plus 3I squared. Let's write a little neater here. 8I plus 3I squared all over 5I squared. Of course, we're not going to leave our answers with those I squareds in there. I get an 8I plus 3 times -1 all over 5 times -1. Okay, let's simplify. 3 times -1 is -3. 5 times -1 is -5. Now, we've simplified this, but what we're going to want to do is write it into A plus BI form, right? So I'm going to go ahead and separate this. 8 over -5 times I, and I have a -3 over -5, okay? Of course, my real part is going to come first, right? When I have this -3 over -5, that's the same thing as a +3 over 5. And this 8 divided by -5 is a -8 over 5 times I. And so this is how I'm going to leave my answer, A in A plus BI form. In this example, we actually have a division by a complex number with a real and an imaginary part. That means that there's 2 terms in my denominator. When we had 2 terms, we multiplied by the conjugate of the denominator. So instead of saying 8 minus 6i, we're going to multiply by 8 plus 6i over 8 plus 6i. All right, and the rest is just simplifying. All right, if I think about it, this sets me up for a distributive property on my numerator. 15 times 8 is 120. 15 times 6 is 80, or 90. So I get 120 plus 90i all over, well, these 2 denominators are what we call conjugates, right? And so if I want to multiply my conjugates, I don't have to FOIL it out. I can square the first term minus squaring my second term. And so I get 120 plus 90i all over 64 minus 36i squared. Again, I'm going to simplify until I get it into A plus BI form. All right. This I squared here is a negative 1, and I have a negative 1 times a negative 36. That's a positive 36. And so we get 120 plus 90I all over 100. Of course, we want to simplify that. We have a 120 over 100 plus 90 over 100 times I. Leave these fractions in simplest form. 120 and 100 have a common factor of 20. All right, 20 goes into 126 times, and it goes in 105 times. And 90 and 100 have a common factor of 10. That'll give us 9 over 10I. And so this is my answer in our most simplified form. All right, we're going to look at one more example with division, and it's this example here. And notice it has it actually in the division form, all right? It has 8 minus 7I divided by 1 plus 3I. What we're going to do here is do it just like we saw that last example, all right? 8 minus 7I over 1 plus 3I, all right? Multiply by the conjugate of the denominator, which is 1 minus 3I over 1 minus 3I. Okay, well, this sets us up for a fall on our numerator. Denominator, we're multiplying conjugates. All right, 8 times 1 is 8. 8 times negative 3I is negative 24I. 7I times 1 is minus 7I. Negative 7I times 1. And negative 7I times a negative 3I is a positive 21I squared. Our denominator, we square the first term minus squaring our second term. Notice here, this I squared is negative 1, so I'm going to keep that in mind as I simplify. I'm going to have an 8 minus 31I minus 21, right? 21 times negative 1 is a minus 21. When I square this 1, I get 1. When I square this 3I, I get minus 9I squared. Again, this I squared is negative 1. When I do 8 minus 21, I get 8 minus 21 is a negative 13 minus a 31I all over a 1 plus 9. All right, and this 1 plus 9, right, since this is I squared is negative 1, and this is a negative 9, I get a positive 9, and if I add 1 to that, I get a positive 10. And so in A plus BI form, I'm going to have a negative 13 over 10. Sorry about that. Negative 13 over 10 minus 31 over 10 times I. And this concludes our study of the complex numbers.